Here we have another problem that's similar to what we just did. At a point 40 meters above the ground, a tower, so here's my tower, at a point 40 meters above the ground, two support wires are connected to the tower. The angles made by the wires to the ground, so these two angles, here's an angle, here's an angle. The wires make a certain angle with the ground. Those two angles are 50 degrees and 70 degrees. And so the question is, number one, we have two questions to answer. Number one, what is the length of the longer support wire? How long is this longer support wire? And number two, how far from the base of the tower is the shorter support wire anchored? How far from the base of the tower is the shorter wire anchored? So this is a right angle, so we don't have that. It would be a good idea. It would be it's not required, but it's convenient to label the picture. And you can pick whatever letters you want to pick. I'm just going to do something that kind of helps me keep straight what's where. So this is wire number one. This is wire number two. I'm going to call this the bottom. I'm going to call that the top. You can pick any letters you want to use. It's just what I'm going to use to clarify this. Now the next piece is, we're given the angles, but we're not told which one is which. We should be able to figure that out ourselves. Even a marginally accurate picture tells us that this inner angle is larger than this outer angle. This outer angle must be smaller than this inner angle, right? The closer you get to the tower, right, this angle gets larger and larger and larger. And so if you're very far away, if you were very, very far away, this angle would be very, very small. The closer this gets to the tower, the closer this anchor point gets to the tower. If the anchor point were very, very close, that would be almost a 90-degree angle. And so it is clear that the inner wire, the shorter wire, makes the larger angle. The longer wire makes the smaller angle. So the 70 and the 50, we know which one goes where and where. We know that, to keep with my little consistency here, we know the 40 is given. We know this angle, that's given to be the 70 degrees. And we know this angle is given to be the 50 degrees. And now the next question is, what are we being asked to find in item number one? What is the length of the longer support wire? Let's call that distance x. That's what we're looking for in number one. Number two, how far from the base of the tower is the anchor for the shorter support wire? Is the shorter support wire anchored? That would be this distance. Let's call this distance y. Well, this is straightforward. We just have two problems really to solve. If you like, this is not necessarily required, because hopefully you can develop enough discipline here that you can simply ignore. If you ignore this piece of the picture, then we just have this large outside triangle. If you need to, it's not the worst thing in the world to separate the picture from itself. If you like, you can separate the picture. Here's the larger outside triangle. Here's the smaller inside triangle. If that helps you, then by all means, just draw those extra little pictures here. But I think we can probably figure now what's happening. Because for number one, and let's do this. Let's say, suppose we want, once again, let's round to the closest meter. So let's round this to the nearest meter. Again, let's just assume that's been given, and we'll play it that way. So, in the large outside triangle, we have this is 50 degrees. That angle is given. From the perspective of this angle, 40 is the side. Again, ignore this line. Ignore this. We're ignoring this line. In this outside triangle, right triangle, this angle is given. Well, this is the hypotenuse of the outside triangle. X is the hypotenuse. And this side is opposite the angle. In the large outside triangle, 40 is opposite this angle. So, for number one, in the large outside triangle, now what is the large outside triangle? W1BT. In triangle W1BT, we have that this angle, this is opposite, this is hypotenuse. Which function involves opposite hypotenuse? We know sine is opposite over hypotenuse, so sine is the function we need to use for this particular problem. So sine of 50 degrees, just say it and write it. Sine of the angle in question, 50 degrees, is opposite over hypotenuse. Cross multiply, set them equal, and solve. When we cross multiply, this way we get x times sine of 50 degrees. Cross multiply this way, we just get 40. Divide both sides by sine of 50 degrees. So we have 40 over sine of 50 degrees. And now, at long last, the very last thing we do, let's go to the calculator. Make sure and show this work so that I can see that you understand the procedure and that you are able to generate a solution. All right, so what's our value? We need to clear this. I'm going to go 40. I'm going to divide by the sine of that's 50 degrees. And I have 52.216. 52.216, yada, yada, yada. But I want to round to the closest meter. And the closest meter, since this is a 2, I'm going to say I'm going to round this, and I'm going to use 52 meters as my final result. So for number 1, the result is 52 meters, and that's the length of this support wire. All right. I'm running out of space, so I'm going to erase this. So you can always go back and rewind the video so you can see this if you like. But now we're going to see if we can solve part number 2. I hope it's going to be equally straightforward, because in part number 2, how far from the base of the tower is the shorter support wire anchored? That is to say, what's the distance between W2 and B? Right? So now we're going to be in triangle, which is a W2, B, T. And we have in the small inside triangle, this angle is given. That side is opposite, this side is adjacent. That side is opposite, this side is adjacent. And so we have which function involves opposite adjacent? I believe that's tangent. Tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So tangent of this angle is opposite divided by adjacent. We have tangent, just say it and write it. Tangent of the angle is equal to opposite over adjacent. Just say it and write it. Tangent of the angle is opposite over adjacent. Cross multiply, set them equal, and solve. So once I think you get the rhythm of these, they tend very often, almost all of these tend to fall into the same basic kind of procedure. Cross multiply, set them equal, and solve. So when we multiply this way, I have y times tangent of 70 degrees. Multiply this way, we just get 40. Again, now divide both sides by tangent 70. So I have 40 divide by tangent of 70 degrees. And now, very last thing, let's go to the calculator. I'm going to go 40. I'm going to divide that by the tangent of 70 degrees. And I have 14.5588. And we're being asked to round this to the closest meter. Since this is 5, our little rule is going to be we're going to round this up. So we would use 15 as our final result. So how far from the base of the tower is the shorter support wire anchored? Our result is going to be 15 meters. And so, I think if you keep your wits about you, if you understand SohCahToa, be careful drawing the pictures. Very often, now remember, on exam day, I will draw the pictures you need. So those will be provided for you. You don't need to really come up with the picture. Now, what you might need to do is to label the picture, but that's irrelevant. This problem is not going to be any different if I just call this A, B, C, D. You can name the points anything you want to name them, but the procedure is the same. What you need to be able to do is recognize what pieces you have been given, what pieces for any particular problem you are desiring to find, and then you choose the appropriate function which involves those two pieces. In the case of problem number 1, we had opposite and hypotenuse. Sine is opposite over hypotenuse. In this particular problem number 2, we had opposite and adjacent, right? So that allows us to find that we would use tangent. Tangent is opposite over adjacent. If in a different problem, if the problem for the angle involves the hypotenuse and the adjacent, cosine involves adjacent over hypotenuse. So you choose the appropriate function which involves the pieces you need. Simply write that out. Just say it and write it, and then every one of these is going to be cross multiply, set them equal, and solve. Once you have your answers found, you can do with them whatever you want to do with them. In the previous example, we found one and found the other and then subtracted to find the third. Once you have these located, then you can manipulate them however you're being asked to do so. But to find the values involves working with the basic trigonometric functions, SohCahToa. Make sure that's in your memory. And you should be able, I think, to work your way through any problem of this sort. They all tend to fall into the same patterns.